Hey guys, this is Shamal and welcome to the AI for Product Innovation series. Today, actually, we're going to be talking about Optuna, which is a hyperparameter optimization framework. Before we get into this, I'm assuming that you have a decent background in machine learning and you know what it actually means to optimize hyperparameters to improve our machine learning models. As we know, like hyperparameter optimization is one of those crucial steps in training our machine learning models. And with so many parameters to optimize and long training time, it can be a cumbersome process. So let's look at an easier way to tune our hyperparameters, right? So I'm going to give a quick tutorial here. I pulled up my Jupyter notebook, and we're just going to go ahead and install the Optuna package, right? And we'll just import it here. As we can see, we're on the 2.10.0 version. And so here, we're going to start with a very basic example, right? So basically, a trial is sort of a process where we're evaluating an objective function that we aim to maximize or minimize, right? So in this case, our objective function actually takes in a trial which sort of has several methods for sampling these different hyperparameters. So in this case, we're just trying to maximize x squared, and we're telling Optuna that, hey, our x can be anywhere from -10 to 10. And then so we create a study, and the direction here is maximize because we're trying to maximize this objective function here. The default, I think, is minimize. So if you don't have this direction here, it will try and minimize x squared. And then we just do study.optimize, which takes in the objective, and we're going through 100 trials to basically get our best parameters, and we're printing them out. So let's go ahead and run this, right? So you can see it finished 100 trials, and yeah, our x value is close to -10, right? Which is expected. -10 squared is 100, and 10 and -10 are sort of our upper and lower bounds, and we're trying to maximize x squared here. All right, so now we're actually gonna go ahead and sort of define a very simple scikit-learn model, right? So we have our objective here. We're loading our good old iris data set, and we're instantiating a random forest classifier for this. And for now, let's just assume our number of estimators and max depth is 5 and 3 respectively. And we're just training and evaluating our model using the cross-val score. So let's go ahead and do that. All right, so accuracy is 0.9733, right, with our current hyperparameters, which is 5 and 3 for n estimators and max depth of the random forest. So now the next step in our process is trying to optimize our hyperparameters. And usually how we would do that is either use a grid search CD in scikit and sort of define different values for the n estimators and max depth and see which one gives a better performance, right? Now let's look at how we would do this using Optuna package. So here, like we saw in the previous first example, we're defining an objective function, which is sort of modified to include a trial object. Again, we're trying to load the iris data set. Now our n estimators and max depth here is basically sampling the different hyperparameters for n estimators, which can be ranging from 2 to 20, and we're saying that our max depth can be ranging from 1 to 32. So let's instantiate the random forest classifier here, which takes in the n estimators and max depth. And again, we're doing a cross-val score to get the accuracy. And we instantiate an Optuna study here, trying to maximize our accuracy for the model and seeing which hyperparameters kind of give us the best performance of our model. So if we go ahead and run that, this will run around 100 trials, print out the accuracy as well as give out our best hyperparameters. So let's see here. So this is 0.973. It's pretty much the same what we saw before, right? But as you can see, the max depth here is 20, and the n estimators that it chose is 13. And I'm just going to try and run this again to see if we get the same value. Let's go to the 100 trials. And actually, we get the same accuracy in this case. It's not changing, but we get a different value for n estimators and max depth, which is 3 and 8.46 relatively. So that was easy, right? You can also sort of like visualize and plot the study if you're curious to see, the different accuracies for our different hyperparameters for each trial. So the visualization here has multiple functions. One is the plot_optimization history, right? Which will plot the optimization history of the study. You can see the one in the red here is the best value, and all the sort of blue dots here are the objective value that we have. And on the x-axis, we have the number of trials, and the max being 100, right? And then we can also plot the accuracies for each hyperparameter for each trial, one for max depth and estimators. And then finally, we can sort of plot the accuracy surface, which gives a nice contour plot with our n estimators and max depth, which are the two hyperparameters that we wanted to tune here. All right, so I hope that helps and gives you a very brief intro into Optuna. It's sort of a first choice optimization framework, at least for me. Pretty easy to use, and you can even set the study's timeout in case you need to take a break and access it afterwards. Optuna is still sort of in development, so they're trying to include more features and trying to improve their algorithm. So yeah, hope you guys like this, and hope you guys use it for some of your projects. Thank you, and have a good day.